Hi there, class. How's it going? Welcome back from an extended weekend. I'm glad to have you guys back. Hopefully, you filled up on lots of turkey and pies and stuffing and all that good stuff. So we're going to continue our discussion about about inequalities. We're going to learn today about absolute values and their equations in inequalities because we haven't really touched on that realm yet. So let's take a look. Things to remember about inequalities specifically is when you multiply or divide by a negative number, you flip the sign. If you have an or statement, you will make two separate inequalities and graph shading to the ends. All right, so an or statement, when you graph it, would look like this. And you may have a statement that says x is greater than 2 or x is less than -1. And then if you have an and inequality, you will create one inequality written like this and shade between the points. So if I were to draw my number line, I were to draw a 0, this might be -2, this is 4, closed dot, or they should be open dots. The previous example was doing closed dots, and we shade between them. All right, so that's what we need to remember about inequalities. And what we're going to learn about is how absolute value ties into this kind of idea of setting two separate equations into one. So when we're dealing with absolute values, those last two rules lead us into what we're doing here. So if you remember, the definition of the absolute value means the distance from 0. So if we're looking for the absolute value of x is equal to 3, we would know that x would be 3 units from 0. But in which direction? So we know 3 units from 0 on a number line. If this was 0, could be 3, or it could be -3, depending on which way we count. So when we solve for absolute values, you have to consider both directions. So you will always get two answers. So in this equation, if we had just the absolute value of x is equal to 3, our answer would be x equals 3 and, or it should be or x equals -3. So we always have to consider the positive and negative values when we're solving equations or inequalities of absolute values. And we'll see some examples coming up here of what I'm talking about. So when we have equations of absolute values, we want to solve like normal. So you still want to go through your steps: distribution, combine like terms, move the variables to one side, reverse order of operations, with the exception that we always undo the absolute value sign last. So we always want to treat the absolute value sign kind of like a variable by itself. So we always want to isolate that absolute value sign. The variable will usually lie within inside of it, or will always lie within inside of it. Otherwise, we know the value of it. So we always want to do the absolute value sign last. So if we have the equation here, the absolute value of x plus 2 equals 9. To get the absolute value by itself, we would subtract 2 from both sides like we would in a normal equation. And now we get the absolute value of x is equal to 7. And similarly as the last problem, in order to solve for the absolute value, we consider both the positive and negative. So our answer would be x equals 7 or x equals -7. That's all we're doing with absolute value. We just have to consider the positive and negative solutions or answers. So in this equation here, this one looks a little different. we already have the absolute value isolated. So as soon as we have the absolute value isolated, we have to consider the positive or negative. So we have to create two separate equations. So we have to think of this as, let me rewrite this. We want to rethink of this as 2x minus 5 equals 13, or 2x minus 5 equals negative 13. So if we did the math for the top one, we would get 2x. If we add 5 to the top equation, we get 2x equals 18. Or if we do the bottom equation, we have 2x minus 5 equals negative 13. Add 5 to negative 13, we have 2x equals negative 8. And then we divide both sides by 2. So our answer would be x equals 9, or x equals negative 4. So we always create two separate equations. Here we have a problem here. Remember, we want to get the absolute value sign alone. So the first thing we do is reverse order of operations. We want to subtract this 12 first. Now we get 3 times the absolute value, 2x plus 9, is equal to 10 minus 12, which is negative 2. Then we want to divide both sides by 3 to get rid of that 3. So we have the absolute value of 2x plus 9 is equal to negative 2/3. So we would want to write this as 2x plus 9 equal to negative 2/3, or 2x plus 9 equal to positive 2/3. So again, we want the negative and positive solution when we get the absolute value by itself. And I'm just going to stop there to set that one up. The important thing is we set up the negative and positive solutions for the absolute value. Now let's look at inequalities. The way we solve inequalities with absolute values varies depending on which way the inequality is facing. So if we have the greater than or equal to sign, we want to think of it as an or statement. So we want to think of this as 8x is greater than or equal to 24. So we always rewrite what is given. Or, now watch what happens here. I want to flip the sign because I changed this to a negative number, right? I multiplied by a negative 1, so I want to flip the sign. So if we have greater than or equal to, we have an or statement. We rewrite the inequality as is, and then we rewrite the inequality, flipping the sign and using the opposite solution. So in this scenario, we would divide both sides by 8. We would have x is greater than or equal to 3, or x is less than or equal to negative 3. And again, if we were to graph that, we have our 0, our 3, our negative 3. We have closed circles at 3 and negative 3. And it's an or, so we shade out. All right, and then one more slide. If we have an inequality with a less than, we want to think of an and statement. Less than and. So we want to rewrite this, and watch, and statements I think are a little easier to set up this way. However, we're not used to completely solving them yet, so that's the more difficult part. When we have an AND statement, we take this number and just put it on the other side with the same inequality sign. So we have -5 is less than or equal to x minus 213. We always put the absolute value in the middle, is less than or equal to 5. And we will see more complex problems in this, but this is a good start. All right, so we want to get that x by itself, so we still add 213 to all the sides. We get -5 plus 213 is 208 is less than or equal to x, which is less than or equal to 218. So again, if we have a greater than or equal to sign, we think of it as an OR statement. If we have a less than or equal to sign, it's an AND statement. Remember, anytime we see an absolute value and we're solving for it, we should think 2 different answers or 2 solutions. Good luck with the lesson, and I will see you in live class.